right, so first of all, an announcement for Tuesday in class. There is some pastors conference thing going on campus here, and they want to come by and see some virtual reality stuff around 10:40. So we'll start class, and then around 10:35 or so, we're going to do some VR demos for folks in this class, so you can mess around with VR, as well as we need to run some demos for the pastors that come through. So we'll spend some time then looking at VR stuff and things like that during class. So, but we will start off with having normal class until 10:30 or so, and then move on to VR demo mode. And that'll be on Tuesday. Okay. So we probably will have several games. We should have Super Hot set up, probably, and then do the your Beat Saber. You have to play all of these. It's a new homework assignment. You shouldn't have to ask what Super Hot is. We had it this summer.
Oh, when I went there for like hours now,
It's so bad.
Well, yeah, but she doesn't.
What?
All right, so we should do Super Hot. We should do Beat Saber. Blaine, we should do Super Hot. We should do Beat Saber, and then probably do like maybe the NBA or the travel demo stuff for on the goes.
Okay.
I think that would be good to have 4 things set up for everybody in here, plus the pastors coming through.
Do you want? Are we using the lab over there?
Yeah.
Okay.
which is that lab.
Yeah.
You mentioned the Opioid VR thing.
The who what?
Opioid VR. Does it have to be next week for Wednesday?
It does.
I won't go to it.
All right. Yeah, that's when they want to meet. Okay, so homework was write a method that takes 2 integers as parameters and returns, Luke,
I know.
the larger of the 2 integers. Make sure you call and test your main method. All right, so just as a reminder, let me pop open this.
Question.
Yeah.
Question. If I find a larger integer, but instead of return, it just prints it. So how many points do I take off?
A lot. So here, let's find the print right here. Printing stuff to the screen is different than returning something.
I know that it's different.
Remember me harping on that last class
Oh, no.
and last semester and putting this in all caps? Okay, it's an important concept. When you have a function that does something and then returns the value for use later, that is different than having a function that just displays something to the screen. Those are different things. All right, so let's go ahead and write this. So we're going to start this guy off with static because that's how we're starting all of our methods off right now. It's going to return an int because it's returning something, Luke. We're going to call this guy find max. It's going to take in 2 integers, int a and int b. And then we are going to ask a question. If a is greater than b, return a. Else, return b. So that's find max. Well, that's a drawn out version of find max, but let's test this first. All right, so I'm going to go ahead. I'm going to say system.out.println find max of 3 and 7. This should print out the result of 3 and 7 after find max returns it to us. So this should give us a 7. There's our 7. if we wanted to capture the value first in a variable and then print out what was in that variable, we might say something like int result is equal to find max 37, and then we can print out the result after the fact, and we might want to do something with that result later. That's the purpose of returning a value. This guy takes in 2 inputs and he spits out a result that we can either choose to store somewhere or we can choose to do something with it directly, whatever we want to do. Okay, but that is different than having it print something inside of here. Okay, so this guy should work for all sorts of different values. If I change this to a 30, it's going to spit out a 30. If I make both of these a 30, it's going to, doesn't matter which of the values it spits out, but it's going to spit out the thing in this else for the 30, so on and so forth. All right, questions about that? Now, I'm going to modify this slightly. Does that code do the identical thing?
No.
Somebody tell me why it does do the identical thing. So we see we get the same result, right? Now, the trick, the thing that's going through your mind right now is when we looked at all those loops, right? We looked at for loops and while loops and do while loops, and we had situations where things looked like they did the same thing, but they didn't actually do the same thing. But this one does actually do the same thing. Why?
Oh, well, if it actually does do the same thing, then.
Or were you going to give me a reason why it doesn't?
Well, yeah, I just.
All right, let's go for that one.
I mean, I was going to say that you have find max 30, 30 up there, so return 30 no matter what. And A is not greater than B is just equal to.
Well, so give me a issue here where this would break the way it's written. So instead of 30 by 30, how could I break it?
You could probably just raise the first integer by like 1.
Okay, so now that's the greater value. So this should
Probably,
should return a 31, right?
Yeah.
Okay, and it does.
Wouldn't it also return? Okay.
And now he's operating. I mean, what you're saying is good for a different reason. He's saying, wouldn't it also return? He thought, okay, well, it's going to get into this if statement, and it's going to find that 31 is greater than 30. So this is going to be true, and it's going to return 31. And then he said, well, won't it also then return 30?
Yeah.
That seems to make some sense, except we consider what does the return statement do? Return statement does the same thing it did last semester. What does the return statement do in a function?
Oh.
The answer out.
Even more so than that. It does shoot the answer out, but what else? What are the other consequences of the
Doesn't it just resolve the entire
method? Immediately ends. Okay, so if we hit this return statement here, we're not alive anymore to get to this guy. That function has concluded. That makes sense?
Yeah.
All right. So this logic, as we have it written here, is identical logic to wrapping the second return B inside of an else. But it's only identical in this case because we have a return statement inside of here. Where if we hit this guy, our method's over. We're never going to get down to this line. Now, if I were to print something in here, just do some math or something in there, something other than a return, then we would still be kicking for this line, and then that could become a problem. Make some sense? The difference between those? Okay. I'm going to write this a scarier way. Now, the way I'm going to show you right now is something called an inline if statement. It is not something you are likely to use very often, but it just so happens to be a pretty good fit for this particular question. So I'm going to say I'm going to return A greater than B colon A, colon B. Is it, oh, question mark, sorry. A greater than B, question mark, A colon B. So first of all, that looks funky, right? Okay, right off the bat. Let's see it work first. So there's our 31. If I make the second value the bigger value, well, it's definitely bigger right now. There's my 303. If I make them the same, it'll still spit out a 303. All right, so we have the same logic here, right? So we have this thing called an inline if statement that came from the old C programming language. And the way an inline if statement works, and like I said, this is something that you might go through your entire career and never use. It's not real commonly used today, but every now and then it benefits you and, you know, saves you a couple of lines or something, and it just happens to be the right tool for the job. Syntax for this guy is Boolean expression, followed by a question mark, followed by true expression, followed by a colon, followed by a false expression. All right. Now you can't have these guys inside of curly braces or anything like that. So what you have for your true and your false expressions need to be truly a single expression. Very simple. Okay. Okay. So we're asking a question here. If this is true, this line will boil down to whatever's right here. If it's false, it'll boil down to whatever's right here. That makes sense? Okay. So we might actually even say that this is the true value and this is the false value. So I don't think you can even do function calls in here. Like you can't say system.out.println inside here. It has to boil down to a value. It's an expression that boils down to a value. So it allows us to have a nice little, you know, concise chunk of code that could potentially flip between two different values. Yeah.
Can you run a method in the true or false expression?
I don't think so. I mean, we could test it, but I'm pretty sure you can't. I think it has to be just a value. You know, so if we come in here and, I mean, running a method is the same thing as saying system.out.println. We're calling a method there, right? And we'll print out A or that, and then afterwards I will, well, first of all, this return thing isn't gonna, that's not gonna be friendly. And then we'll just return A here, something like that. Wants me to use this. Yeah, see, this guy wants to fire out a result. So I'd have to give it, well, we'll make a little get val. So we'll give ourselves a little waste of time method there. Something like that. So get val, since this does boil down to a single value, that appears like it should work. So I would have to give it the greater value as the first one. So we'll make this 304, and then it'll end up returning 304. Yeah. So as long as the method you're calling boils down to a single simple value, it'll work. But this guy does boil down to a value. All right, so that's really more of a trivia thing. I probably would not ask you on a quiz or a exam or something like that to write something with an inline if statement. If you ever run into something that looks freaky like this, it's, you know, this is more information for that, because it is kind of syntax that you might see specifically in some older programs. I mean, you might see it in a newer program as well if the developer has been writing stuff for a while because it's knowledge that they might have been, they may have used more often in an older language. But inline if statements are a thing. Okay. So you could have written this one more concisely using an inline if statement. It just happened to be the right tool for the job. Tell you what, this mouse is terrible. Something like that. Make some sense? All right, so questions about this find max thing? Make some reasonable sense? Okay. And everybody's clear now on the difference between returning a value and printing a value? Okay. So let's go and let's talk about string methods now. So we started talking about strings last time, and we mentioned that strings are collections of char primitive types surrounded by double quotes. So that could be anything that is on the Unicode character set. So that's all of our English letters, that's spaces, that's punctuation, that's numbers, that's characters from a whole bunch of different languages. Any of those things in between double quotes makes a string. Okay, now strings also have methods associated with them. So strings are what are known as object types as opposed to primitive types. All right, so strings in, remind me, what's a primitive type? Go ahead.
Ints, char, long.
Those are examples of our primitive types. So what are primitive types? If you were to give a definition for a primitive type, what would you say? You answered it last time. So it's a variable type, or it's a type built into the language that's only capable of holding a value. Only capable of holding a value. Doesn't have any additional magic tricks. All right. Where our object types can potentially do more. They can hold 0 or more values, and they can also have methods associated with them. All right. So we're going to look at some of the string methods. There's a whole bunch of string methods, but we're going to look at some of them that are commonly used. That way we can, create hard homework assignments involving these methods. Right? Yeah. Still fascinates me. This assignment was difficult. Like, measure this last assignment compared to merge sort.
We don't talk about that.
So we're going to write merge sort again in here.
I almost want to
All right.
It's okay. We can use that as a reference because I lost it.
I had a funny thing with one of the grad classes the other day. We're going to write this in here as well, actually before too long. And then this whole thing will make more sense because it's not that hard of a program, but some of the grad students in this class were just wimpy. How many of you have heard of a thing called Conway's Game of Life? It's actually, it's a simulation of, there's like rules associated with it. You have, when we do 2-dimensional arrays, probably next week, I'm guessing, we'll probably have an assignment dealing with this, where you have, it's like 2 rules. It's not overly complicated rules, but you watch these, the idea is you have either living or dead entities on the screen, and each iteration you apply the rules to it based on how many neighbors that, each grid, each XY position has. If he has exactly 3 living neighbors, he remains alive. If he only has 1 living neighbor, he dies from not having enough friends. If he has more than 3 living neighbors, then he dies because of overpopulation, stuff like that. So it kind of creates these cool looking patterns on the screen and stuff like that. And I was having dinner with some grad students who were in Dr. Locklear's class, who have this thing as an assignment for, I think was due last night, actually, I think. So the terror is over for them, I guess. And they were talking about how this thing was so hard, and they made, they spent zillions of hours on it and stuff like that. So You know, we're sitting there eating. So I downloaded a Python interpreter on my phone and I wrote it on my phone while we're sitting there at dinner. It looks really cool. I'll show you what it looks like. And it was only like 100 lines of code. But that's what it ultimately does.
That's cool. You just need a Python interpreter for that?
Well, I mean, we're going to write it in Java in here.
Oh.
But it's not, it's really not that difficult.
Well, yeah, I can imagine.
So these wimpy grad students, I mean.
I mean, that's just a learning, like, prepare for your turn.
Would you rather do that assignment or merge sort?
I think that would be more fun.
That'll replace merge sort.
We'll do them both. We'll do both of them.
Yeah.
Yeah, but that I mean, we're gonna do that like in 2 weeks. It's not gonna be
Really?
Yeah, it's not hard.
What have been climax to? Oh, that's right. We're getting the apps. That's right.
Yeah, but this is not like.
No.
Yeah, but the hardest part of that is just you have to clear the screen. That way it looks like an animation, right? Because it's kind of a slideshow. Like here's the grid again, here's the grid again, here's the grid again, and, you know. And if you have it, you know, one after another, then you don't get the. It looks like a movie effect, right? So you just that's the hard part is clear the screen.
Okay.
It's easy, just times 100.
Well, I'm not expecting you to write it on a cell phone. I'm just saying the fact that I could sit there at dinner and write it on a cell phone kind of indicates the true level of complexity of the problem, right? You know, you wouldn't sit there and write that many projects on a cell phone.
Unless you want to reference.
I can't see the phone. I can't even see it. All right, so we're going to talk about some of these string methods that we have. One of the methods we have is a method called length that takes no parameters. I'm actually going to write the method header here. So it takes no parameters and returns an integer. Okay, and this guy returns the number of characters in the calling string. Okay, now what do we mean by the calling string? So now we're going to start stepping into that thing where I've said we're just going to put static in front of it just because. We're not going to quite answer that yet, but now we're starting to walk into that territory. With us, so far, actually, I'm going to show it here in a second. I'm going to go ahead and create a string. Here, I'm going to put this up on Slack real quick with the one-line thing. The inline if statement. There's my thingy-majig function.
Thingy-majig.
Can I edit this? Oh, no, it does that. Edit message. Oh, whatever. There. I'll title them that way they don't all get lost. Okay, so we're gonna mess with strings here. So get rid of this dude. They're getting so bad. I had to make sure the curly brace was still there. It all kind of blurs together. All right, so I'm going to create a string hello like this. Actually, I'm going to just back up here for a second. I'm going to leave my find max in there just so I can show you a difference here in a moment. Okay, so we'll create a string called S. This guy will be equal to hello. And then if I want to go ahead, I'll create a variable for this just so we can see that returns a value. So I'm going to say int the length of S is equal to S dot length. All right. So here is the name of my method, length. Since we know it's a method because it has an opening and closing parentheses, it takes no parameters as I have advertised here. Length takes no parameters. I've also advertised that it returns an integer. That is, it returns one, Luke. Okay, return.
I literally had that conversation with Austin yesterday, and I was like, you think I should change that? Because I don't have it returning, I just have it printing out. It's like, maybe you could go change it real quick. And I was like, nah.
So, hold on. Now you're implicating Austin. You didn't help him? Did you know the difference?
Well, no.
I told you to change it. You said I'll do it.
Yeah, we already knew that.
Well, you shouldn't have told him to change it. You had already submitted it.
No, yeah, I already knew the difference too. I was like, you think I should change that? And he's like, maybe if you go resubmit it quickly. And I was like, nah.
That's just a bad friend.
It's
It's like, look, yeah, it's wrong. Look, should I change it? I'll do what you want. like whatever you think. All right, so here's the name of my function. We know it's a method or a function because we see the opening and closing parentheses there. It doesn't require anything to work. And what it does is it returns the number of characters that lives inside of the calling string. That guy right there, the dude that called this particular string. I'm going to create a second string here, string S2, and I'm going to set this guy equal to elephant. Elephant. And we're going to have this guy int the length of S2 is equal to S2.length. All right, so this is the same function called length that takes no parameters, but he will return the number of characters that live within the calling string. And in this case, the calling string is S2. And I happen to be just storing the result of those two guys inside of these variables that I've named the length of S and then the length of S2. So very specific variables. We know exactly what kind of value those guys are going to hold, right? All right, then we'll go ahead and print these out. System.out.println. The length of S. Length. See, this is why you have shorter variable names because you can't spell them. System.out.println. The length of S2. All right, so I'm going to print out the value of those two variables. The length of S should be 5 because that's the number of characters that are in S. The length of S2 should be 8. That's the number of characters that are in elephant. Okay, so we should have a 5 and an 8 appear on the screen. Okay, but they only appear on the screen because we chose to print them after they return their value, Luke. V thinks she's like dodging the bullet here. Yeah. It's this way. All right. Okay. So in this case, the calling string is the instance of the string class that we use to call this particular string method. Make some sense? All right. So now we're going to create, well, let me show you the flip side of this. Now, I'm going to go ahead and we're going to print out find max. So we're going to do system.out.println. So I'm choosing to print the result of calling find max. So I'm going to say find max and we'll pass it 23 and 45. So in this case, this guy should spit out a 45 because it's the larger of the two values. So there's my 5, my 8, my 45, right? Okay. Find max, return that value. I just happen to be directly using it and printing it. Okay? Now, I've purposely been calling our methods like this up to this point, just to not confuse the issue. But up to this point, I've mentioned that, oh, just throw static in front of your methods just because. right? You would often find programmers call find max this way anyways. I don't. I will always call this method by saying driver dot find max. All right, so let's talk about that means. Notice that driver is the name of my class. Because this guy has the keyword static in front of it, that means it's a class method. When static is not in front of it, it's an instance method. So static sitting in front of this means it's a class method, means it's owned by the class. How do we call class methods? We call them using the name of the class in which the method was defined. All right, so let me get some stuff out on some slides here, and then we're going to come back and we're gonna test some people and think they know the difference here. Okay, and then I'm hopefully going to prove the point of why you should always use the thing here. So for those of you who already have had a bunch of programming, be prepared because you're the target in a minute. Okay, so we're going to come in here. So we're going to talk about method types. So we have class methods. Now class methods, when they're being defined, have static in front of them. This is when we are defining the method, when we're originally writing a method, not calling it yet, not using it. When they're being used, they are called using the name of the class in which the method was defined. All right, so when I'm defining a class method, I put the keyword static in front of it. When I'm using it, I call it using the name of the class in which that method was defined. Okay, so let me drive just that first point home here. All right. When I'm defining a class method down here, this is where I'm actually writing it. I'm defining it. Have not called it yet. I put the keyword static in front of it to make it a class method. Okay. We're not even talking about why we would make something a class method versus not making it a class method yet. Just trust there's a reason for right now. Okay. But I put the keyword static in front of this guy means that he's a class method. When I'm calling it, like right here, I'm calling find max, which is a class method. How do we know it's a class method? Because when we look at its definition, we see the keyword static in front of it. And how do I call class methods? Using the name of the class in which the method was defined. This method was defined inside of a class called driver. So here's my method. It's defined between the opening curly brace and the closing curly brace of driver. Therefore, I call it using the name of that class, driver dot find max. Okay, now one benefit of writing it this way is now I can go in here, I can say driver dot, and it will show me all the class things associated with it. And one of them is find max, this very first one. I can press enter on it, and then I can give it my two values. So I don't have to worry about misspelling. So that's one perk. Okay, and I used that same example with the this keyword when we're, which we'll see. This is the same thing as self from last semester. In Python, we had a keyword self, which is how an object refers to itself from within itself. We'll see that in here shortly. But in Java, instead of being spelled self, self is spelled this. So, you know, it's a zig instead of a zag, but it means the same thing. Okay. All right, so questions about class methods, other than when would we create a class method? We'll get to that. Right now, just assume that they sometimes exist, and if we are writing a class method, we have to put static in front of it. If we're calling a class method, we call it using the name of the class in which the method was defined. All right, go ahead.
Question. I see you said like s dot length, so that is it. S is the class method.
No.
Okay.
Hold off on that for a second. Okay. No, it's a good question because that's exactly where we're going with it. Because this is length is an instance method. So we didn't write length, somebody else wrote length. And I promise you, when we go and look at length, if we look at where it's defined, it will not have the word static in front of it. And I kind of demonstrated that. You got your picture?
No, I did not.
Oh, you didn't get it? All right, go.
Yeah, I'll get it later. I need to delete one.
All right, so I've kind of demonstrated that over here when I showed you these string methods. Length int is what it returns, but I did not put static in front of it. So when there's not static, so this is kind of like, I didn't actually write this, the logic inside of it, but this is the method header for when that method was being defined. So it does not have static in front of it. So if we come down here and we add to this slide, instance methods. And now, first of all, this slide, this is a top 5 most important things you can learn about programming languages, knowing the difference between class methods and instance methods. The knowledge on this slide unlocks the entire Java documentation for you. And when you read through it, you're going to say, oh, well, this isn't that hard, blah, blah, blah. Commit this to memory. You should, if we have flashcards that we just pop up and say, here's the method definition. This is class method or instance method, you should know. Okay. If I show you a method being called, you should, and I say, was this guy a class method or instance method? You should know. Because what are you looking for at definition? You're looking for whether or not the static keyword is there. What are you looking at the time it's being called? Whether or not it's being called with a class or with an instance of a class. Okay. So instance methods, when they're defined, do not have static in front of them. That's it. They don't have that word in front of it. That's the differentiating factor between a class method and an instance method when they're being defined. Oh, man, he is out.
Yeah, the whole class.
All right, so these guys do not have static in front of it. All right, so when we're looking at method definitions, that's the distinguishing factor. If I show you a method, I say, is this guy a class method or an instance method? I'm showing you the definition. All you have to hunt for is that word static. If it's there, it's a class method. If it's not there, it's an instance method. Pretty simple, right? I promise you, you're going to confuse that. Commit this slide to memory. Trust me. Super, 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 super important. Okay, and it's going to be one of those mantras we have through the semester. Like, how do you call class methods? How do you define class methods? You know, class methods are defined with the keyword tag. How do we call them? We call them with the name of the class in which the method was defined. That kind of stuff. And let me write the other part of this. So when we use an instance method, these guys are called using an instance of the class in which the method was defined. Okay, these are called using an instance of the class in which the method was defined. Go ahead.
Question, is it like the instant method is usually the built-in? No.
Not necessarily. We're going to write instance methods and we're going to write class methods.
Okay.
So that's not a fair statement to say that if it's built into the language. What she was saying, is it fair to say that if it's built into the language, it's probably an instance method? Not necessarily. That's why this slide's so important, because when we go and look at documentation for stuff that's built in, and we want to say, well, how am I supposed to call this guy? By looking at its definition, we can say, has static in front of it, I need to call it using the class name. Or it doesn't have static in front of it, I need to first create an instance of this class, and then I can call this guy using that instance. Okay, and let's see that in action here. I promise you, in fact, here, I'll just show you. Just for completeness. I'm going to go to java.sun.com because that's where I know. Then I'm going to click on Java SE. Here, I'll blow this up a little bit. I'll click on Java SE here. Then Java APIs over here. And then pick your poison. All the stuff we're doing has been in Java for literally decades. So I want to do the frames version of it. Yeah, this is the one I'm used to seeing. So the core Java language, if you come up here and you see there's a zillion things. So Java is a big language. There's lots of stuff in here. if you just scroll down to, actually, I think, didn't it change? It's no longer java.lang. I think I saw this. Here, I'm just going to go find string in here. So this is a list of all classes that exist in the entire language. Not really what you want to scroll through.
Yes, please.
Especially not with a very temperamental mouse. String. Oh, so close. All right, here's string. It's like java.core or something. Java.base. So up here, if I had found java.base, it used to be called java.lang. Yeah, right up near the top. If I click on java.base here, now this list of stuff down here, even though it's still a lot, it's a lot less than we just had. So this is showing you the stuff that's built into Java when you first start a program. This is the stuff that's just available to you without you having to do anything else special. Okay, so I'll go down here. I'll find my string. So here's string. Then over here, I'll make this a little bit bigger. I'm going to go down to the method definitions. So here's fields, here's constructors. Don't worry about those for right now. Here's methods. I'll just happen to go down to our length method, although we are, well, let me just show you length first. Here's length. Notice it does not have static in front of it. Just returns an int, no static here. All right, and notice that there's a couple here that have static in front of them. So when I want to join two strings together, I can use, here's some static methods. Don't worry about that for right now. But, you know, as a general rule, as you scroll through strings here, a majority of the string methods do not have static in front of them. Therefore, they are instance methods. Therefore, we require an instance of the string class in order to use them. We actually have to create a string first and then use it. And that's what I've done right here. I've created two strings right there, string S and string S2. So we would say that S is an instance of the string class. We would also say that S2 is an instance of the string class. Therefore, we can use those two guys to call the various instance methods of the string class. And I'm using S to call his version of the length method that knows everything there is to know about S, including how many letters are in it, how many characters are in it, as well as S2's length method, which knows everything there is to know about S2, including how many characters are in there. That makes some sense? Okay, so now, here's my test for the folks who have, I'm really asking the question for the folks that have programmed in Java, C#, or C++ for a while. So who are those folks? Probably, okay, so we'll let you two are the guinea pigs. All right, so I'm gonna guess, I'm gonna especially guess with you that you don't usually put the class name in front of it. Am I right?
Sometimes, not at all.
Okay, good. So this works. We've seen it work. My question is why does it work? Because I'm going to make the argument that you're only allowed to do this if you actually know why it works.
Good question.
It's an excellent question, isn't it? And the answer can't be, well, I've done it before and it just worked.
So the fact that the method works when we have the class method and you're not calling driver, you're saying. So the fact that it is a class method and we're not using it.
Yeah, I'm actually making the argument that this driver dot thing is there. It's implied. In this particular case, when I just say find max, it actually is implied that driver dot is in front of it. And that's why you don't actually have to write driver dot.
Is it because if it's not specified, it assumes that it's within the class that you're
Okay, we're about a third of the way there. Why does it make that assumption in this particular case?
because main is static.
That's it.
Oh,
That's it. Okay, since main is a static method, anything that's happening inside of main is considered to be happening within something called a static context. Okay, so put it on a slide. First of all, I'll say this. This little knowledge thing we just came to here, you don't even have to worry about if you just always put the class name in front of it. It's never wrong. Like it's a class method, call it with the name of the class. You never have to wonder whether or not it was supposed to work or not. It'll work. Okay, but let's just add to our knowledge base here this idea of a static context. All right, so we have something called a static context. And contexts, even just that word is somewhat scary, especially when you see it in programming stuff. You know, like, well, what does that even mean? So, static context, this guy exists within a static method. So within that method, we're living in a world governed by the static context. It's almost like the flavor of the air or something like that. Okay, so, you know, we're breathing static context air. And so when we're in an environment like that, so within that context, the name of the class is implied in front of method and field calls. Don't worry about fields yet. We're going to talk about them when we start writing our own objects. We've learned about them. We learned about it last semester. You know, last semester we wrote our own objects, like the dice object, and the dice object had constructors and it had fields. Like the fields were like number of sides and number of dice. You know, things like that. Those are fields. These are variables owned by a particular class, but we haven't written it yet in Java. So, you know, but believe me, if we had some static fields at the top of our driver class here, we could directly access them just by their name instead of saying driver dot if we wanted to. Okay, and I'll actually talk about that again because there's even more reason to call them using driver dot. And that has more to do with variable scoping rules. It's faster to call them directly that way. All right, so when we're in a static context, that means we are in a method that has static in front of it. Anything that happens inside that method, unless we otherwise write the code to bypass this, will be assumed to have, so the name of the class is implied in front of method and field calls. So if we did not put it here, if we didn't say driver dot inside of find max, it's presumed to be there because we are living inside of a static context. That make sense? But my argument would be because find max is a static method, which means it's a class method, lives inside. How do we know it's a class method? Because it has the keyword static in front of it when we defined it. How do we call class methods? We call them using the name of the class in which the method was defined. The name of the class this guy was defined in is called driver, so we call him by saying driver dot find max. Make sense? You'll never be wrong if you follow that rule of thumb. And you'll probably misspell less often using a modern IDE like Eclipse that does command completion. Okay, as opposed to the length method, which we just went and looked at in the documentation, and then I also wrote in our slide that did not have the word static in front of it. Therefore, it must be an instance method because when we looked at its definition, we did not see static in front of it. It's an instance method. How do we call instance methods? We call them using an instance of the class in which the method was defined. Okay, now this is a little touching point for us. Some people might say, well, don't I need an instance of driver since we're inside of the driver class right now? The driver class is not the class in which the method length was defined in. The method length was defined inside of a class called string, this guy here. So there exists a class called string that has a non-static definition for a method called length. Therefore, in order to call that guy, I need an instance of the class in which the method was defined. I need an instance of the string class. That makes sense? So here's my instance of the string class, s.length, s2.length. Here's me calling these two instance methods using instances of the class in which they were defined. Good.
In what situation that the instant method is more useful than the class method?
It's not a useful versus not useful. It's right. It's what's the right tool for the job. Let me show you an example of this. So I'll introduce another method for strings here real quick for this example. String methods. So there exists a method in strings that returns a string called toUpperCase, and it takes no parameters. And what this guy does is it returns as a string, the uppercase version of the calling string. Okay, because this guy's an instance method, we call him using an instance of, in this case, the string class. Therefore, the calling string would be the instance of the string class that he was called with. Okay, so let me show this guy work here real quick. So I'll go ahead and print out s.toUpperCase. And then I'll also go ahead and print out s right afterwards. Okay, what this is going to prove is that when I say s.toUpperCase, this guy returns a new string, a brand new string, which is the calling string in uppercase. It does not change the original calling string. All right, so in this particular case, s will still be lowercase hello. So that lowercase hello will print out here. But uppercase hello will print out here because I'm printing out the value that's returned by having s call his toUpperCase method, which gives you a copy of s in all uppercase. So there's hello and hello, upper and lowercase. That makes sense? All right. Now, these guys are instance methods. We're calling them with instances. Now I'm going to show you an alternative toUpperCase. So we're going to look at this class called the character class. And inside the character class, we have a function called static char toUpperCase. And this guy takes a char c as a parameter, and this returns c as a uppercase char. All right, that's what that guy does. So notice it has static in front of it. What does it mean if it's the definition has static in front of it? Class method. How do we call class methods? By the class name, or this is our mantra. You know, we get to have like the creepy hum using the name of the class in which the method was defined. And just stare straight ahead, you know. All right, and I'll show you this in the documentation too, just for completeness here. So we'll go over here to the character class. I'm already in Java. Is java.lang still there? Oh, java.base has java.lang inside of it. There you go. Now you have a lot less stuff, right? So java.lang is the stuff that's actually included inside of default Java program without you having to import anything special. So we'll go ahead and scroll down here. We find the character class. Here's the character class. We're going to scroll down to the method summary. So here's the method summary. First of all, we start seeing a pattern. We see a lot of static keywords here, right? So the character class is filled up with a whole bunch of static methods, where the string class was filled up with a whole bunch of instance methods. And one of these methods in here is called toUpperCase. We'll get down to that guy here. toUpperCase. Right here. So it's static, returns a char called toUpperCase, takes a char as a parameter. Pretty much matches what I had in my slide. Okay, so we need to call this guy using the name of the class in which it was defined. It's defined inside of the character class. So I'm going to come in here and I'm going to say system.out.println character.toUpperCase, and I'm going to pass this guy a lowercase a. Okay, this guy's a char primitive type. How do we know this is a char primitive type? Single quotes around it. Okay, so we see the single quotes, must be a char. All right, so character.toUpperCase takes, first of all, notice that this guy takes a parameter. This guy did not take a parameter. So that's a starting point thing for us to notice. I'm going to ask you why here in a second. Go ahead and play this. We'll see we get an uppercase A there. There's our uppercase. Well, almost. There's our uppercase. Our uppercase A is there. I must just be bad at the math. This is my my tremor hand. So I must just be constantly moving my finger on the mouse as I'm trying to like highlight stuff. I don't know. This mouse is too sensitive. All right. So why is it that the toUpperCase method, I mean, because right off the bat, these two methods, they have the same name. So they must be related, right? We've seen their functionality. They both convert stuff to uppercase. So they do a very similar thing. But the one that lives in the string class doesn't take any parameters. The one that lives in the character class requires me to pass it a char. Why is that? Go ahead.
Because the one character.toUpperCase is a static method, so it's not tied to an instance, so you need to give it something.
Okay, so it doesn't know about any specific char. So to kind of flip it around, the toUpperCase method for strings, it knows what string we want to convert to uppercase. It knows about the string that called it, and it's converting that string to uppercase. So he has access to the calling string. So instance methods will have access to the information associated with the instance that called them. Whereas class methods, like this, do not have access to the information about the instance that called them because they're not called with an instance. They're called with a class name, character. So if I didn't provide anything in here, he might say, okay, I mean, I'm prepared to convert something to uppercase for you, but I have no idea which char you want me to convert to uppercase. You didn't give me that information. That makes sense? Difference there? All right, so then the follow-up question, weird, oh, whatever. The follow-up question would be, why is it that why did they write toUpperCase as a class method inside of character when they wrote toUpperCase as an instance method inside of S? As we went through strings and characters, we noticed in strings, pretty much every method was written as an instance method. And we looked through character, pretty much every method was written as a class method. Why is it that they chose to write the methods inside the character class as class methods? They had a decision. They could have written those as instance methods, which would have then required you to create an instance of the character class in order to call them. They could have done that, but they didn't. Why not?
Was it a other issue, if I'm right?
Well, the short answer is no, but I'll let you argue that if you want to go deeper, because you probably could make a compelling argument that that might be a thing. I'd like to say I believe in you. But I'll refrain for the moment.
Would it, I mean, back when Java was written, it was written to be platform independent on a ran on a virtual machine. So any little thing that would have saved it, like
Well,
time,
how might this save it memory?
because you're calling it directly from the class instead of creating an instance.
Yeah,
Quicker.
yeah, it's not gonna be it's not gonna work out. So why do they choose to make this guy a class method? Go ahead.
Well, I mean, just looking at it right now, the char is only one character. It's not that much to type in. Seems kind of silly to have to find as a variable before you would use it.
Okay. Let me give you a documentation-based hint.
Okay.
About that? Be a documentation-based hint. So I'm going to go down here. I'm just going to find here's the class called double. I'll scroll down here. Notice that the double class has a whole bunch of static stuff in it too. And I'll go down to the long class. Long class has a whole bunch of static stuff in it too. So why is it that the character, go ahead. You got that?
Like, is it just like you could do it either way? I guess like whichever way would be easier for you with the program you're writing. So like, with the static method, you would have to like write that out. Or with the instance method, you'd have to like you can have it like throw in like a whole bunch of different strings. While with the static, you'd have to like write out like a whole bunch of like it manually like a bunch of times.
Well, I mean that's true. So the folks over at Sun Microsystems, when they wrote this, they had to make the decision. When they were writing the character class, they had to decide, do I make the to uppercase method in the character class, do I make that a static method, or do I make that an instance method? They chose to make it a static method. And one of the side effects of that was that they don't, in order to convert chars to uppercase, you didn't have to create 50 instances of characters. You could just, it just kind of acts like a factory. You toss it the char you want it to convert to uppercase, and it just does it. It does the magic for you. Okay. What? That still doesn't answer. I mean, we'll call that a part of an answer, but that still doesn't really tell us why it still is the best tool for the job to make this guy a class method. Anybody else want to take a stab before? All right, go ahead.
So it's just it's a primitive type, so it's not an object type. Therefore, instances aren't generally something you do with a primitive type. You don't instantiate a or a
That's true.
char.
Yeah, they're primitive types, so all they can do is hold a value.
Correct. So you wouldn't have an instance of it. Therefore, it's primitive type. It needs to be static.
Well, that's true with a primitive type. So you're saying we couldn't call it with a primitive type. That's true, but we could have it. We could create an instance of a character object, and then call it with that instance of a character object. Yeah. So I thought you were going down the right path.
I think it's third.
And he's on those wooden wheels, and he hit one of those rocks. Close. We've actually almost said the whole answer. Here's another hint. Primitive types can only hold a value. Can only hold a value.
That means cannot hold more than a value.
that would. The phrase "can only hold a value" would indicate that it cannot do more than that. Yes, that's okay. So either hint works. So since primitive types, so you've pointed out that this involves primitive types. Okay, and you've pointed out, how did you point it out? That they can't do more than hold a value. Okay, so primitive types can't do more than hold a value. I'll throw out another question. Might we want to convert characters to uppercase? Is that something we might be interested in? Might we also be interested in knowing whether or not a particular character is uppercase or is a digit or stuff like that? We have all sorts of functions for that too. Or is white space? You see this guy right here? We have all sorts of ways of asking, is a particular char a member of this group? Now, what's the difference between an object type and a primitive type? Okay, well, primitive types can't do more than hold a value. So primitive types can only hold a value. What about object types?
0 to whatever. And then also with the method.
Okay, so they can hold 0 or more values, so they can potentially hold lots of values at once. And then they can also do other stuff, functions, and they have constructors, all this stuff like this. Okay. Now, in this case, we have a method that we want to perform on char primitive types. Do I need the character class to hold primitive chars? Let's assume this guy didn't have any methods in it. Should the character class exist just for the purpose of holding a char primitive type? Or do I already have a way of holding char primitive types? I have a primitive type called char, right? That can't do anything more than hold a value. See, I told you. Okay, so I already have the ability to hold a char. That's the extent of the ability, but I have that ability. But now we've agreed a minute ago that it might be helpful to ask some questions about chars or to do some things to chars. Therefore, it's kind of nice if we can just create this kind of factory that sits there. That I can throw a char at it and say, make this uppercase. And then he spits it back out to me. I don't need him to remember the char value that I give him. I don't need to have 30 of these factories, one for an A, one for a B, one for a comma, stuff like that. I just need one factory that I could walk in with a char and say, I need the uppercase of this guy. So I'm giving him that value right here. I walk into this factory. It's a class method. This method exists one time ever. It's owned by the class itself. I walk in the door with the char primitive type that I want him to operate on. He does his job and kicks me out the door. Because I don't need a new way of storing characters. But it is helpful to have a way of manipulating characters. That's why the character class is filled with class methods. That makes sense? Okay. Now, one thing we will run into in 300, we're just giving a punchline. So here I'll confuse you. So a minute ago, I asked the question, do we actually need an object type way of holding a character? Now, our quick answer would be no, because we already have ways of holding chars, right? Char primitive type. But if we look in here, just kind of foreshadowing, we go all the way up here to the constructors, which we saw in 200. This is the way to create one of these objects. Notice that there is a constructor. It's something called deprecated right now, which means it's going away. But we do have a constructor for the character class that takes a char primitive as a parameter, which allows us to kind of get this really fancy box to hold a char primitive type. It still is only holding a char, but it's holding it inside of a box that makes that char an object type. Because every now and then, we might need primitives to pretend to be objects to hold them inside of certain kinds of data structures. And that'll make sense in 300, but that's why something like that would have made sense. It has nothing to do with us converting it to an object so we can call instance methods, because you see all the methods are still class methods. It has more to do with, I have this tool over here that requires me give him objects to hold generic objects, and I have a non-object thing here called a char. So I'm going to stick it in this box to make it an object, and I'm going to hand him that, even though it's still just a char. Just put it in an envelope or a box or something like that. Make some sense? Okay, so questions about any of that? Homework for next class. We're going to keep practicing with our methods. Write a method that takes a minimum and a maximum value as a parameter and displays, not returns, displays, this guy's going to print out values. Okay, this is the other way around, and displays all the values counting down from maximum to minimum. Method, multiple parameters, doesn't return a value, instead it displays some stuff. Gonna have to write a loop, but this loop, instead of going from minimum to maximum, it's gonna go from maximum to minimum. So you're gonna show me you're practicing with loops. Make some sense? Questions, comments, concerns, bribes? Decent chance of a quiz on Tuesday, probably having something to do with class methods versus instance methods. So that slide you might want to commit to memory. All right, I'll see everybody on Tuesday.
I'll see you later today.
Oh yeah, do we have a quiz today?